Hello Math 12 or 30-2s, and we're about to start the second part of our permutations with repetition. So if we take a look at this here, now we're going into exploring roots using permutations and patterns. Basically, we have these little patterns here, and it's like pathfinding. It's little pathfinding patterns, and we have these roots. We have to figure it out. So we have Paul and Catherine. They are considering the following problem. How do we get from point A to point B without going backwards? So from point A to point B without going backwards. So this is what they do. Paul first decides, he says, hey, I have 10 different ways of doing this. And he goes, the first route is this way. Then he goes the second route. Then he makes a third route. And he goes maybe this way. Then he continues finding ways to go all the way to B. And it keeps on going and going. Now, if you look at this, if it's a bigger square, that takes a long time to do. Catherine's a very intelligent girl, and she looks at it, and she realizes that it is set up after kind of like repetitions. There's an order. We go east 1, 2, 3 times. We're going south 1, 2 times. So we have different orders. We could have east, 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 and then south, south. Or we could go east, south, east, south, east, and so on and so forth. So she's looking at all of these combinations, and that's what made her think, well, this is very similar to permutations. It's the order of 3 E's and 2 S's. But there's a repetition. It's how many orders can we get 3 E's and 2 S's? There's 5 ways of going there. So 3 E's, 2 S's. So altogether we have 5 to choose from. And we're looking at what's repeated. Well, we have 3 E, and we have 2 souths. 3 easts, 2 souths. So when she does this, she ends up getting a total of, puts it in her calculator, she'll get 10 different paths. So that's the way she looks at it. Another way of looking at it would be, think of your length and your width. So it's length plus width, factorial, all over length factorial multiplied by width factorial. That's another way of looking at it. Okay, so then there's a third way of doing this here. This might be the easiest way. It's not the fastest, but it could be the easiest way, and sometimes this is the best way of doing it. So here they looked at it, they just rotated our shape. So we took this shape here and we rotated it. And he had different things. So it's kind of like a Plingle game. Now, start here, we're going from A all the way to B. So how many ways is there to get to C? We only have this one route. How many ways is there to get to D? Only one route. Then we go to E, there's only one way to get there. We can only go here and then here to get to E. If you drop the ball from A to get to E, you can only go here and here. Now to get to F, it could go here and then down there, or it could go here and then down there. To get to H, we could go here, here, and then here, or we could go here and then here. Or we go here, here, and here. So there's 3 ways. So if we continue this, over here we get 1, 1, 2. 1, 2, 3. So if it's an addition. So we look at the 2 corners. 1 plus 2 is 3. 1 plus 1 is 2. And the outsides are always kind of 1, because there's only one way to get there. But now this outside isn't going to be, because there's 1, 1, 1 way. So this side here, 1, 1. 1 way. Now, we take our 2 corners and add them. On this side here, there's only 1 corner, so we can only add from here. There's no other corner, so it's just from here, 1. There's no other corner up here, so we can't add. Same idea here, there's no other corner here, so we can't add, so it's just 1, it just continues. So now we look at it here, and we have 2 and 1. To get this, how many we want to find here? We have 2 plus 1 is 3. Okay? And we go from here to get to this corner. We have 3 and 1 is 4. So we look at the 2 corners that connect to this one. So let's take a look at this here. Which two corners connect? We have 3 and 3, so this is 6. And altogether we have 6 and 4, which is 10 to get to this corner. So to get to B, there is 10 different ways to get to B. Pretty straightforward. We'll go through more of these later. So then it says, how do the answers relate? Compare F, C, and D. Well, they are, F, C, and D. This is for this one here. How do F, C, and D relate? Well, let's take a look. We have F is, F, C, and D, how do they relate? So, here's F, C, and D, we add C and D, so we add the corners to get F. Okay, how do H and E compare? Or how does H compare to E and F? We look at H, we add E and F together, that gives us H. How does I compare to F and G? For I, we add F and G together, that will give us I. And it keeps on going that way. Okay? Now, use the relationship in the second diagram and compare your answers with Paul and Catherine's. Well, all of them equal 10 paths. Okay? We look at the first one, that could be the longest way. The second one is probably the fastest way of doing it. The third one is in between, but you have less chance of making a mistake. Okay, so let's try this next question here. So this next question, a supervisor of the city bus department is determining how many routes to go from the bus station to concert hall. So we're going from here all the way to here. And we want to find all the routes possible to go from there to there. Now, we could do it the long way and count each one. We could go all the way this way, and then over and then down. We could go all the way this way, over and down. We could find all the routes, but there's a better way of doing this. So let's find using the pattern. So the patterns is one of the easiest ways. We're going to flip it onto its side. Okay? So I could have one way here, one there. 1, 1, 1. 1, 1. Now, to get to this point here, there's one way here or one way there. So there's two ways to get there. This and this, we add these together. We're going to get 3. We add the for this corner here, we add those two corners. We're going to get 4. And for this corner here, we add these two corners. We are going to get 5. Now let's look at this one. For this point here, we add this in this corner, we get 3. For this and this corner we add to get here, we're going to get 4. Add these two corners, and that's 6. We add these two corners, we're going to get 10. We add these two corners, we get 10 here. Add these two corners, we're getting 15. Almost done. Add these two corners, we get 20. Then we add these two corners, we're going to get 35. Now, there's 35 ways to get to this corner. Now, how many ways are there to get to this corner? There is no corner, another corner adjacent to this dot. So, it's going to be 35 continued. Now, to get to this corner, same thing, 35. We look over, we have this corner, it's going to be 35. And then here again, 35. Because we cannot go this way, then back up there, because then we're going farther away from concert hall to go back up. So we can only go this way, here we can only go this way. So it's 35 for all of those. Now we look at this point here, we have 35 ways to get there, or we could go to 35 ways to get there, and that gives us 70 ways. Now this last place here, we have 105 ways, 70 plus 35. And then we have this place here, which is 105 as well, and altogether there are 210 ways to get to concert hall. Now, that is A. Now let's take a look at B, which is the permutations and combinations way. So if we look at B, we have two different rectangles. We have a rectangle here and we have a rectangle here. So remember we looked at our formula to find the permutations for a rectangular city block. If it's squared perfectly, it's length plus width factorial all over length factorial multiplied by width factorial. Okay? But we have two squares here, and we'll get to that later. So let's take a look at this here. So using permutations with repetitions. So we have how many east? We have 1, 2, 3 east, and we have 1, 2, 3, 4 south. So it's 3 east and 4 south. So it's 3 plus 4. Factorial all over. Now we want to know we have 3 factorial multiplied by 4 factorial. But we aren't done there. We have to do this. We go through this path, and then we have to go through that square. Okay? So there's an and there. And if we remember back, and always means multiplication. So we have that and, which means we must now multiply. So we have to multiply the next square. Well, let's take a look at the next square. We have 1, 2 by 2. So that is 4 factorial, or sorry, I'll write it all out. Not skipping a step. So we have 2 plus 2. Those are the dimensions. Factorial all over 2 factorial multiplied by 2 factorial. So if we simplify this, I'm going to get 7 factorial all over 3 factorial multiplied by 4 factorial. All that multiplied by 4 factorial all over 2 factorial multiplied by 2 factorial. And what we will end up getting is when we do that, we should get the exact same answer as before as 2 tenths. And that's how we do that. So if I didn't have to explain this, the second way here is a lot faster than the first way. And there's a lot less ways to make mistakes. It's so easy sometimes to make a mistake adding up, or going too far, or accidentally putting a 1 here, or missing a step. Okay? Now, let's look at example number 4. So we have a taxi station, and he's trying to get to the football stadium. And this is the grid of the town in order to get to the football stadium. Now, a taxi company is trying to find the quickest route during rush hour from the train station to the football stadium. So we're going to use first the patterns and routes. Okay? So use patterns to determine the number of routes. So let's take a look at this here. So there's only one way to get here. One way to get here. We have only one way to get here, because to get here, we can only continue going down to get here. We cannot go this way, and back, because that's going away. It's no longer the fastest. One again, one. Okay, now, let's take a look at this a bit more. So we have all the fastest, we have the ones all done. Now we have to start adding everything up. So what's 1 plus 1? Is 2. 1 plus 2, 3. This corner here, the 2 adjacent corners we add together, we're going to get 4. Add the 2 adjacent corners together, we're going to get 5. Here we add the 2 adjacent corners together, we are going to get 3. And we add the 2 adjacent corners, we get 6, 10, 15. Here we're going to add, we're going to get 4. We have 10. We have 20, 2 adjacent corners, 35. Now, if I look at this one here, there's only one adjacent corner to this guy, and that's 15. There is no other adjacent corner, line connecting directly. Okay, but now this guy here has 2, and we have 15 and 35, which will give us 50. Okay? Now, going from here to here, there's only one adjacent corner, and that's that 4. So from here to here, we have 14. Okay? Now, from here to here, we're going to have 34. From here to here, we're going to have 69. And then, in our very last one, we go 69 plus 50, which will give me 119. So that's how we do that. Now, it says down here, explain why permutations with repetitions 9 and 5/4 cannot be used to determine this. Well, when we're using back to this formula up here, we always have to have perfect squares in order to do that. This one here, we do not have perfect squares. There's overlap here. It kind of overlaps a bit. These two squares, like there's a square like this, and there's a square like this. They kind of overlap. Now, because they overlap, we cannot use that permutation combination, our usual formula. So we cannot use this combination. Okay? And that is the gist of all of your permutations and combinations, permutations when it comes to using paths and finding paths for everything. I hope you enjoyed the lesson. I hope you understand. If you have any questions, ask me tomorrow while we go over it again in class. And good luck on your assignment.